So I just did the video for 12.1 and 12.2. Kind of felt like it might have sucked a little bit, but hopefully that doesn't keep you from doing well on the homework. I'm going to do 12.3. And 12.3, to me, it's a bothersome section. Odds are just, to me, not intuitive. They're not particularly hard. It's just that the answers just never seem like I want them to be. So there are odds against an event happening, and then odds in favor of events happening. And if you're gambling, usually if you go to a horse track or see like the odds for someone to win a Super Bowl, it's an odds against. And in order to find odds, you must be able to do probabilities, because odds are very related to probabilities. We say the odds against event happening is the probability that the event doesn't occur divided by the probability the event does occur. And there are definitely shortcuts that, as I'm going through the section, you might be able to kind of shortcut the formula a little bit and get the odds quickly, which would be good. So here do my first example of doing an odds. Determine the odds of not rolling, or the odds against rolling a 2. The odds against rolling a 2 is the probability of not rolling a 2 divided by the probability of rolling a 2. So to do odds against, it's the probability of the event not happening. So the odds against rolling a 2 are going to be the probability of failing to roll a 2 or not rolling a 2 divided by the probability of actually rolling a 2. So the odds against something are the probability of it not happening divided by the probability of it happening. I'm going back to the rolling a dice because that's an easy experiment to visualize. When I roll a dice, I can get the numbers 1 through 6. To do the odds against rolling a 2, I need to know the probability of rolling a 2 and the probability of failing or not rolling a 2. The probability of rolling a 2 is 1 in 6. There's 6 things that can happen, and of those 6 things, 2 is the only good number. So the probability of rolling a 2 is 1 in 6. The probability of not rolling a 2, I could roll a 1, a 3, a 4, a 5, or a 6. The probability of not rolling a 2 is much greater than the probability of rolling a 2. There's a 5 in 6 chance. So the odds against rolling a 2 are the probability of not rolling a 2 divided by the probability of rolling a 2, or the probability of failing to roll a 2 divided by the probability of succeeding rolling my 2. So the probability of not rolling a 2 is 5 in 6, divided by the probability of rolling a 2, succeeding to roll a 2 is 1 in 6. This is tricky. Fraction of top of a fraction, I usually rewrite that with a division. 5 over 6 divided by 1 over 6 as a fraction can be written as 5/6 divided by 1/6. And I'm going to invert and multiply and make this 5/6 times 6 over 1. And I'm going to cancel. And I'm going to get on the top 5 and down low 1. And I'm going to write a non-reduced fraction. I'm going to say the odds against rolling a 2 are 5:1 are 5 to 1. And what this means is I'm 5 times as likely to roll a 1, not roll a 2, that I am rolling a 2, because there's 5 things that can happen that aren't 2s, and 1 thing that happen is 2, and 1 times 5 is 5. So the computation for finding an odds against is the probability that the event that you want doesn't happen divided by the probability that you want the event does happen. You form a fraction over a fraction, change to a division, invert, multiply, cancel, reduce, write your odds with a colon or the word 2 between the odds. The numerator is written to the left of a colon, the denominator is written after the colon or the word 2. So the important thing is the odds against an event are happening is the probability of the event not happening divided by the probability of the event happening. So you have to be able to do probabilities to do odds. The odds in favor of an event are the probability that the event happens divided by the probability that the event doesn't happen. So the odds in favor are the probability that the event happens divided by the probability that the event doesn't occur. Where the odds against, it's just the reciprocal. It's the probability that the event doesn't happen divided by the probability the event does happen. And once I do the fractions, I simplify and I write the odds as a ratio or colon. So here, if I wanted to find the odds, so the odds against rolling a 2 was 5 to 1. If I want to do the odds in favor of rolling a 2, so the odds in favor of rolling a 2, it's going to be the probability that the event occurs, so the probability that I roll a 2 divided by the probability that the event doesn't occur, that's divided by the probability that I don't roll a 2. So the odds in favor of rolling a 2, the probability of rolling a 2 is 1 in 6. The probability of not rolling a 2 was 5 in 6. If I write this as a division, that's 1 in 6 divided by 5 in 6. Then I'm going to make that division into a multiplication by flipping the fraction. So it's going to be 1 in 6 times 6 in 5. I'll cancel out the 6's and be left with 1 over 5. I say the odds in favor of rolling a 2 are 1 to 5, where the odds against were 5 to 1. It's always going to be the case if you know the odds in favor, you flip them, you get the odds against. If you know the odds against, you flip them, you get the odds in favor. So the odds in favor of rolling a 2 is 1 colon 5. The odds against rolling a 2 is 5 colon 1. So it's important to know the definitions for odds. Odds are probabilities of something occurring divided by something not occurring, or divided something not occurring by the event occurring. You write your fractions, make a division, flip and multiply, reduce the fraction, and then write your odds with colons or the word 2. Usually we write colons. The author consistently writes colons in his answers. So now I dug out some problems from the text, hoping that that's enough. And real quickly, I start to get the issue that as we get deeper into the chapter you're going to have. You have to understand what question is being asked before you can answer it. And there's a difference between probability questions and odd questions. Sections 12.1 and 12.2 we did probability, and the author sneaks some probability questions in section 12.3, and then in addition to the probability questions adds some odd questions. So this particular problem is 12.3, number 10. It talks about Ann Kelly. She has 14 bills in her wallet, and she's going to randomly dig into her wallet and give one to the Salvation Army. The first questions are probability questions. Probability questions is just going to be one fraction. And for each of the probability questions, the denominator is going to be 14, because what Ann is doing is she's closing her eyes, reaching into her wallet, and pulling out one bill. She has 14 bills in her wallet, so there's any one of 14 bills that she can get. And for probability computations, the denominator refers to the number of events that can happen, and what Ann can get is she can get any one of her 14 bills. The numerator needs to contain the number of bills that have the look that I want. For part A, what's the probability that she gets a $5 bill? Well, in her wallet, of the 14 bills, there's 2 $5 bills. So I'd say the probability of her getting a $5 bill to donate is 2 in 14, which I'd reduce to 1 in 7. For part B, the probability that she doesn't select a $5 bill, which means she can pick any 7 of the $1 bills, or she can pick any 4 of the $10 bills, or her one $20 bill. The probability that she doesn't select a $5 bill is picking one of the other 12 bills that aren't the $5 bill. So it's going to be 12 and 14, which I can reduce by 2 to 6 and 7. So now I need to do odds. Odds in favor and odds against. Fortunately, these probability questions that the author asked are going to be useful. The odds in favor of selecting a $5 bill is going to be the probability that she selects a $5 bill divided by the probability that she fails to select a $5 bill or does not select a $5 bill. So I have those fractions. I even have them reduced. The probability that she selects a $5 bill is 1 in 7. The probability that she doesn't select a $5 bill is 6 in 7. I'm going to write that as a division. That's 1 in 7 divided by 6 in 7. I'm going to change it to a multiplication. That's the same as 1 in 7 times 7 in 6. I'm going to cancel the 7s. That gives me 1 in 6. And the odds in favor, I'll say, are 1:6. The next one's the odds against. I could just flip it and write 6:1. That would be the slick thing to do. If I know the odds in favor, I flip it and I get the odds against. If I wanted to do the long way, the odds against is the probability that she doesn't select a $5 bill divided by the probability that she does select a $5 bill. So in favor is the probability of the event happening divided by the probability of the event not happening. The odds against are the probability of the event not happening divided by the probability of the event happening. And I have the numbers again. The probability that she doesn't select a $5 bill reduced to 6 and 7. The probability that she does select a $5 bill is 1 in 7. I'm going to write that as a division as 6 and 7 divided by 1 in 7. I'm going to invert and multiply and make it 6 and 7 times 7 and 1. I'm going to cancel my 7s and get 6 over 1, which I'd write 6:1. So any odds that the author wants us to do, it's just a matter of dividing two probabilities. If you're slick, you might be able to get your answer to odds kind of bypassing the probabilities. I'll leave it to you to be creative. If you figure out a way to be creative and figure out odds differently, there are definitely slick ways to get odds that I won't get into. All right, so 12 wants me to find some, and 14 wants me to find odds against. So anytime it's an odds question, I need to know if it's an odds in for or odds in favor or an odds against. The odds against an even number, so I'm rolling one dice. It's the odds against, it's going to be the probability that I don't roll an even number. That's the failure, divided by the success, which is the probability of rolling an even number. So to do the odds against, I have to know what probabilities I'm dividing. And for the odds against, you want the event not happening in the numerator and the events happening in the denominator. Now I need to be able to do the probability. The probability of not rolling an even number would be rolling a 1, 3, or 5, which is going to be 3 and 6. The probability of rolling an even number, that would be rolling the numbers 2, 4, and 6. That's also 3 and 6. I could reduce each of those fractions to 1 and 2 if I cared to, but I won't. Now I'm going to write this as a division. This is 3 and 6 divided by 3 and 6. flip and multiply. This is 3 and 6 times 6 and 3. Cancel the 6's and the 3's to 1's. Multiply across the numerator. I need to leave my answer as a fraction. Across the numerator, 1 times 1 is 1. Across the denominator, 1 times 1 is 1. The odds against rolling an even number, I'll say it's 1 to 1. It's even money. There's basically a 50-50 chance. Next one is problem 13. The odds of rolling a number odds against rolling a number greater than 4. The denominator is going to be the probability of rolling a number greater than 4 because it's odds against, so the denominator needs to be the success. The numerator, since it's odds against, it's the probability of the event not happening. It's going to be the probability of not rolling a number greater than 4. Now I need to be able to do the probabilities. I know each of the probabilities is going to have a denominator of 6 because there's 6 things that can happen. Rolling a number greater than 4 would be rolling a 5 or 6. Not rolling a number greater than 4 is a 1, 2, 3, and a 4, because a 4 is considered not rolling a number greater than 4, because all 6 numbers need to be considered. They're going to be somewhere here. They're either going to be part of the success or part of the failure. Rolling a number greater than 4, there's only 2 numbers that count greater than 4, and then not rolling a number greater than 4, that's the other 4 numbers. So when I do my odds, I have to contain all the 6 numbers in the dice sample space here. So this is going to be 4 and 6 divided by 2 and 6, which is 4 and 6 times 6 and 2. I'm going to reduce the 6's to 1's. I'm going to reduce the 4 to 2 and the 2 to 1. The fraction that's left is 2 over 1. And I'll say the odds against rolling a number greater than 4 is 2 colon 1. The odds in favor would be 1 colon 2. So every odds problem is just a matter of determining which probabilities that you want to divide, and very specifically, you have to find out if the author is asking for an odds against or an odds in favor, and the author will always tell me which ones he wants. Ooh, 16 and 18 are card problems. So, and the author wants both odds against and odds in favor. The nice thing is, once I compute one, I'll flip it to get the other one. So the first thing I'm going to do is find the odds. I'll do against picking a heart. So in this problem, one card is drawn from a deck of cards, and I want the odds against getting a heart. That's going to be the probability of failing to get a heart, so the probability that the card's not a heart, divided by the probability that I actually get a heart. So success is getting a heart, failing is not getting a heart, and odds against has the failing to get what you want in the numerator, and it's the succeeding to get what you want in the denominator. And card problems imply that you know lots about cards. To do the probabilities, you have to understand what cards are being counted. For each probability, when I'm picking one card from a deck of cards, there's 52 cards in a deck of cards. I'm picking one of them. So each probability, the probability in both the numerator and the denominator, is going to have a 52 down low, because regardless if I'm finding the probability of picking a heart or the probability of not picking a heart, both of those probabilities, I can pick one of any 52 cards. The denominator is easier for me. There's 13 hearts in a deck of cards. So getting back to that handout that we did in the last section, you have to know a deck of cards perfectly well to answer probability questions or odds questions with cards. The probability of getting a heart, there's 13 cards in the deck of the 13 hearts in a deck of 52 cards. In the numerator, the probability of not getting a heart, the things that would be considered not hearts are the clubs, spades, and diamonds. There's 13 clubs, 13 spades, and 13 diamonds. 13 clubs plus 13 spades plus 13 diamonds. There's 39 cards in a deck of cards that aren't hearts. This 39 non-hearts and the 13 hearts take care of all 52 cards. Now I'm going to reduce this fraction by writing it as a division. I'm going to write it as 39 over 52 divided by 13 over 52. Now I'm going to invert and multiply. I'm going to go 39 over 52 times 52 over 13. I could have reduced the fractions earlier, but I'm going to reduce them now. I'm going to cancel the 52s, and 39 and 13 reduce. 13 divided by 13 is 1. 39 divided by 13 is 3. When I reduce this fraction, I need a fraction, so I can't dump the 1. It reduces to 3 over 1. The odds against picking a heart is going to be 3 colon 1. I don't need the parentheses, but I just snuck it in there. And then the freebie, find the odds in favor of selecting a heart. I'm just going to reverse it. I could do the whole computation, but it's not necessary. The odds against and odds in favor are always just flips of each other. Ooh, 18 is a really tedious problem in terms of counting the things that you want to count. So I'm going to find the odds against picking a card greater than 5. And then this requires even a better understanding of cards. So this is going to be the probability, the denominator is going to be success, the probability that I get a card greater than 5, and the author says to count the aces low. And then the numerator is the probability of not picking a card bigger than 5. Each of the probabilities is going to have a 52 in the denominator because I can get any one of 52 cards. For the cards bigger than 5, I'll do the denominator first. To picking the cards bigger than 5, it's going to be a 6, and that 6 could be in a heart, a diamond, a spade, or a club. It could be a 7 of hearts, diamonds, spade, or club, an 8, a 9, a 10, a jack, a queen, and a king of each one of those suits. 8 of hearts, diamond, spade, and club. 9s of hearts, diamond, spade, and club. 10 of hearts, diamond, spade, and club. Jack of hearts, diamond, spade, and club. Queen of hearts, queen of diamonds, queen of spades, queen of clubs. King of hearts, king of diamonds, king of spades, and king of clubs. So the numerator, the probability of picking a card greater than 5, I'm counting all of these cards. And that's 1, 2, 3, 4, 5, 6, 7, 8 times 4. There's 32 cards of the 52 cards that are greater than 5. So the denominator, the probability of the denominator happening is 32 and 52. There's 32 cards in a deck of cards that are greater than 5. The numerator is not picking a card greater than 5. That's going to be an ace because the author told us that the ace is supposed to be low. And then a 2, a 3, a 4, and then because I haven't counted the 5, I have to count the 5 because a 5 isn't greater than 5. So that's going to be 4, 8, 12, 16, 20. So the probability of not picking a card greater than 5 is any ace, 2, 3, 4, or 5, and there's 20 of those. So for this particular odds computation, it's 20 and 52 over 30 and 52. And I'm going to write that as 20 and 52 divided by 32 and 52. Now I'm going to invert and multiply. I'm going to make it 20 and 52 times 52 over 32. I'm going to cancel the 52s. 20 I'm going to divide by 4. 20 divided by 4 is 5. 32 I'm going to divide by 4 and get 8. The odds against getting a number greater than 5 is going to be 5 colon 8. And I'm pinched for room, so I'm just going to write odds against and odds in favor and not write the rest of the problem next to the answer. The nice thing about odds, once you have the odds against, you can get the odds in favor by just flipping it, or once you have the odds in favor, you get the odds against by just flipping it. So every odds computation that the author was going to want us to do is a computation that involves dividing probabilities. The probability of a success divided by a probability of a failure, or the reverse. Okay, so more odds and odds against. So if you pause and do 23 ahead of me, you're doing a good job. So the odds against selecting a woman is going to be the probability of not selecting a woman divided by the probability of selecting a woman. Each of the fractions is going to have a 30 in the denominator because I'm picking one person from this class. The class has 16 men and 14 women, so there's 30 people. The probability in the denominator of selecting a woman is 14 and 30 because 14 of the 30 are women. Odds against the probability of not selecting a woman means selecting a man, which is 16 and 30. So the odds against selecting a woman are going to be 16 and 30 divided by 14 and 30. I'm going to invert and multiply, so I'm going to go 16 and 30 times 30 and 14. Cancel my 30s. 16 divided by 2 is 8. 14 divided by 2 is 7. I'll say the odds against selecting a woman is 8 and 7. And if I want to do the odds against selecting a man, the denominator is going to be the probability of selecting a man. The numerator is going to be the probability of not selecting a man. Each probability is going to have a 30 for its denominator because there's 30 people that I can choose from. In the denominator, the probability of selecting a man is 16 out of 30 because there's 16 men of the 30. In the numerator, the probability of not selecting a man means the probability of selecting a woman, which is 14 and 30. And then if I do this, this is 14 and 30 divided by 16 and 30. Flip and multiply. This is 14 and 30 times 30 and 16. The 30s cancel. I reduce the 14 by 2 to 7. The 16 by 2 to 8. I get the fraction 7/8, and I'm going to write 7 colon 8 as the odds against selecting a man, which would be the same as the odds in favor of selecting a woman, but we won't get that tricky. So I'm being very consistent in doing my odds using probabilities divided by probabilities. There are definitely ways to speed through the process bypassing the formula, but that requires being clever. If you get to be that clever, that's wonderful. But if you just drudge through these formulas, it'll take you to the answer every time. Ooh, 675 asks me, or he says, the next problem says, use the diagram on page 675 to answer the questions, which means I couldn't draw something well enough, or if I drew it, it would be embarrassing, so I chose not to draw it. So the drawing on 675 that I want is this thing that has pool balls on it, or billiard balls, and there are solids, there's stripes, like the 15's a stripe, the 1's a solid. There's billiard balls from 1 through 15. 8's still considered a solid, even though it's somehow magical in a game of pool for some games. But anyways, there are 1, 2, 3, 4, 5, 6, 7, 8 solids, the numbers 1 through 8, and 7 stripes. The numbers 9, 10, 11, 12, 13, 14, and 15 are all stripes. There's 8 solids, 7 stripes, and 15 balls in general that we're looking at. So when I go to answer the question, what are the odds in favor of a ball being even? So the odds, if I'm picking one ball, in favor of getting an even, that's going to be the probability of getting an even ball. That's the success that needs to go in the numerator because it's in favor, by the probability of not getting an even ball. And if I'm just randomly selecting one ball from the rack, the denominator is 15 because there's 15 billiard balls that are being looked at here. And in the numerator, I need to count up the evens. The 2 is even, the 4 is even, the 6 is even, the 8 is even, the 10 is even, the 12 is even, and the 14 is even. So the even balls that I'm worried about are the 2, 4, 6, 8, 10, 12, and 14. So that's 1, 2, 3, 4, 5, 6. There's 7 even. So the probability of getting an even is 7 and 15. The odds are the 1, the 3, the 5, the 7, the 9, the 11, the 13, and the 15. And there's 8 odds. So the probability of the odds in favor are the probability of getting an even, which is 7 and 15, by the probability of not getting an even, which is 8 and 15, which I can write as 7 and 15 divided by 8 and 15. Invert and multiply, I'll go 7 and 15 times 15 and 8. Cancel out the 15s. The 7 and 8 don't reduce. It's going to be, the odds are 7 and 8. 28 is the odds against a stripe. That's the probability in the denominator that it has a stripe. In the numerator, the probability against means not having it. So it's going to be the probability of not having a stripe divided by the probability of having a stripe. Both of the probabilities are going to have 15s in the denominator because there are 15 balls that I can choose from. In the numerator, the not having the stripe, the ones that don't have the stripes are 1, 2, 3, 4, 5, 6, 7, and 8. Those are solid balls. There are 8 balls that don't have stripes. The balls that have the stripes are the 9, the 10, the 11, the 12, the 13, the 14, and the 15. There's 7 that have stripes. So the probability of not having a stripe when you pick a ball is 8 and 15. The probability that has a stripe is 7 and 15. To do the odds, I write the fraction as a division. Do 8 and 15 divided by 7 and 15. Invert and multiply. That's 8 and 15 times 15 over 7. Cancel the 15s. The 8 and the 7 don't reduce. And I say the odds against it containing a stripe are 8 to 7. I think there's one last problem to work with. A real similar problem. So we have a box that has 9 red and 2 blue marbles, so it has 11 marbles. I randomly select one. What's the odds against selecting a red? That's the probability in the denominator that I select a red. And since it's odds against, in the numerator, that's the event not happening. That's the probability that I don't select a red. So the odds against selecting a red have the probability that I don't select a red by the probability that I select a red. Each of the fractions is going to have an 11 in its denominator because the box has 11 marbles in it. For selecting a red, there's a 9 in 11 chance that I select a red because 9 of the 11 marbles are red. There's a 2 in 11 chance that I don't select a red because only 2 of the marbles aren't reds. So I make a fraction. I go 2 in 11 divided by 9 in 11. That's the same as 2 in 11 times 11 and 9. I cancel out the 11s, and the odds against selecting a red marble are 2 colon 9, or 2 to 9. that's all I have for the section. I did mostly problems from the book, which hopefully means that when you get into the section, it makes sense. Yeah, as I look through here, there are definitely more problems in the section, but hopefully you can do them all. If my video kind of is lacking and there's a bunch of problems I just didn't do enough on, yell at me and I will do my best to fill in the gaps of what I left out. All right, so I'm gonna set this video up on my webpage now, so hopefully you get a chance to watch it this weekend.